Okay, so let's get started. We're going to be taking a look at setting up and working with our closed loop style boost control in our Motec M1 programming. Our last training module, we explored our open loop control. That's where we just command a certain amount of duty cycle in a feed forward table, and that's going to be indexing looking up from our boost target, and that's what the Motec's going to run for the boost control to the boost control solenoid. Now in this training module, we're going to be exploring the closed loop, which is taking the open loop control a step further and allowing Motec to adjust and feedback to the values that we figured out in the open loop control. Now I am going to go over some of what we've covered in the last training module, just so if you're skipping over the open loop control and coming in here, you have an idea as to what's going on here. Things will make a lot more sense. We're also going to be going over some configuration and details in the beginning of the tutorial here, making sure you have your boost control set up and configured properly so that the actual closed loop or boost control in general will function as we're desiring. So we're just going to turn up our boost, not create over boosting or any kind of odd boost control problems. So let's jump in here and take a look at where we can find our closed loop control for our programming and boost. We're going to go here from field tuning and move over here into boost setup. Now boost setup is going to be where we do our configuration and most of the setup for the open loop style control, and then we'll find we have our boost PID. That's going to be where we program our PID gains as well as some of our clamps here for the integral clamps, and we can see how the entire system is performing so we know what to adjust. Should make very, very clear at the end of the tutorial exactly what is going on within your closed loop control. Now we're going to be doing this on an engine simulator because it's much easier to keep things in a controlled environment when we're talking about the boost control, so I can slow things down. You can see exactly how the PID gains are applied, and you should understand how they're going to work so that when you're actually doing tuning on a real engine, it's going to make a lot more sense. Again, slowing things down just definitely makes things a bit more clear here in the boost control strategy and routine. So let's jump over here into our boost setup, and we're going to be discussing first setting up our boost control solenoid, whether we're an internal or an external wastegate. Now I'm going to be covering how to set up a 3-port boost solenoid. 4-port solenoids are an option. I try to avoid using them because they're very coarse in adjustment, meaning a very small duty cycle change can lead to a very big manifold pressure change, boost pressure change, which isn't desirable, especially when we're talking about a closed loop format, because the Motec is going to be essentially feeding back to what we command here in our feed forward values. This is going to be where we start for duty cycle and makes adjustments to those values to get to the desired boost. Because there's a very coarse relationship between the duty cycle and the boost, that makes the closed loop control unstable in a lot of cases. We get a lot of oscillations and generally hard to control. So the 3-port is going to be what I always try to use on most applications. The only time I introduce a 4-port solenoid is going to be in a very high back pressure situation where the exhaust back pressure is going to be much higher than the inlet manifold pressure, and as a result we have to have a little bit more control over the wastegate, and the 4-port allows a better control compared to a 3-port. But in all their situations, a 3-port is going to be superior to give you better resolution, better duty cycle to manifold pressure change as we're going in and calibrating everything. So coming up on screen here, the first picture we're going to go over here is going to be how we route our vacuum lines from a 3-port solenoid to an internal wastegate with a turbocharger. So we're going to find on our 3-port solenoid, we have 3 ports, port 1, port 2, port 3. Port 1 is going to be open to atmosphere, vent to atmosphere. You could recirculate it back into your intake tube, but you don't need to. You can vent it to atmosphere. Then we have our port 3. That's our pressure into the solenoid. That's coming typically from our compressor cover. That could also come from your inlet manifold. That's so after the throttle body. You could also take it from the charge pipe, but it has to be a pressure source coming in. Then we have our port 2. Port 2 is going to be what we send the control out from the solenoid to the nipple on the internal wastegate actuator. Now in this orientation, when we're not energizing the solenoid, this is known as a normally open solenoid configuration. So it's normally open, meaning the pressure is going to flow through port 3 and then it's going to go flow to port 2. When we have our pressure reference going to the actuator into that nipple on the internal wastegate, that'll crack open at whatever the rated spring pressure is in the internal wastegate assembly. So if you have a 5-pound, 10-pound, 15-pound actuator, that's what it's going to open at, and it should regulate your boost there with no interference or control from the boost solenoid. Now when we start to apply some duty cycle output control, 0 to 100 is our range for adjustment from the Motec, that's going to be energizing the solenoid. That's going to be starting to bleed some of the pressure that normally would go through port 3 and then to port 2 to the internal wastegate and bleed it out port 1. We're effectively going to be dropping the pressure reference to the internal wastegate actuator, which is going to keep the swing arm from moving keep that flapper door shut and start to increase our exhaust mass flow going across the turbine wheel and the turbocharger. That's going to allow the turbine to spin faster, which spins the compressor faster, which generates more boost. So 0% means we have no output to the solenoid. That'll act like we have no boost solenoid there, and like you have just a vacuum reference going right to the actuator, and it'll run off spring pressure. 100% from our boost control solenoid in this situation has no pressure going to port 2 and essentially going to the maximum boost that the system can build. Now there will be a certain amount of exhaust back pressure that starts to build, and it starts to blow open the flapper valve or door on your turbine housing. It starts to bleed off the exhaust mass flow naturally. Normally with the internal wastegate, we can double the rated actuator pressure with our boost control solenoid. So meaning if we have a 10-pound actuator with the 3-port solenoid, we can typically reach 20 psi boost. Now that may not always be the case. You might be able to reach a little bit more, but typically you can count on a 2-to-1 ratio. So you can double your wastegate spring. Now we can't turn the boost down, so the actuator is going to be the minimum boost that we can run. We can only increase the boost past the wastegate spring, wastegate actuator, whatever it's rated at. All right, now let's move on to a external wastegate. The external wastegate is going to have, in this particular picture, we're going to find we have our boost control solenoid, we have our turbocharger, we have our external wastegate. External wastegate has 2 ports for control, a lower port and an upper port. Now on the lower port control, that's going to go to a pressure reference on something like our compressor cover. It's also going to be sharing that pressure reference with our port 1 on our boost solenoid. Now port 3 on the solenoid configuration, that's going to be normally open, vented to atmosphere. And then our port 2 is going to go to the top port on the wastegate hat. And we'll find in this configuration, when the solenoid's not energized, we'll have no pressure going from port 1 flowing into port 2 and into the top hat of the wastegate. So if we have a 10-pound spring in our wastegate, so we can change our springs out, a 10-pound spring will build 10 pounds of boost, and we can only increase beyond that 10 psi.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.